Hello, welcome. My name is Daniel Plaisted. I work on the .NET team at Microsoft, and I'm going to talk about MSBuild and some of the stuff that's been going on with that. We'll cover kind of the journey that we had away from MSBuild a little bit to Project.json and back and why that happened, and then a lot of the improvements that have come in Visual Studio 2017 and that are coming in Update 3 for MSBuild and .NET Core and .NET Standard projects. And then we'll look at basic MSBuild concepts so that you can understand how to customize your build, and we'll see how to investigate, see what's going on with the build, figure out what's going wrong, and we'll look at, in these new style of projects, kind of the defaults, some of the defaults that apply and how to modify those if you need. So I joined Microsoft in 2008 because I just loved .NET and I was really excited about it. And I ended up on the MEF, the Managed Extensibility Framework team. That was one of the first open source .NET projects at Microsoft. And I say quote unquote open source because it was open source in the sense that periodically we would take the source and we would copy it over to Codeplex. But there wasn't any mechanism to accept contributions. And if you wanted to change the source code and use your own version, there was no really easy way to recompile it with your changes and then drop it in as a replacement. So I'm really happy with what we've been doing over the past several years with the .NET framework, moving to, almost everything is open source. It's open source by default, getting lots of great contributions, having development in the open and everything. But that doesn't mean that, we've done everything perfectly. There's been some bumps along the way. So first I'm going to get into a little bit of the background of what we've been doing for context. And so we have the .NET framework. This is the platform that we have that has traditionally supported desktop and web apps mainly. And then Xamarin is based on Mono. That's another .NET platform that supports iOS and Android apps. And then the new thing is .NET Core. This is a completely open source and cross-platform version of .NET. It runs on Linux, on macOS, and on Windows. And each of these kind of has different app models for the types of apps you can build with it. And they each have their own base libraries. So there's the base class library set for each of these frameworks that has stuff like file I/O and collections and link and all of this basic .NET stuff that you're used to. And that the reach of .NET is great, but when you want to target .NET, having a separate base class library for each one wasn't a great job, and so a great thing to do. And so what we have is .NET Standard, and this is basically a unified base class library that says that the same APIs, base APIs, will be available across all of these platforms. And if you've been following the past few years, for the past 5 or so years, we had something called portable class libraries. And I worked on those too. And to me, .NET Standards is kind of the new and improved version of portable class libraries. So it does do the same things. It's better, and I don't have time to go into the details of that, but I'd be happy to talk to you about that afterwards. But what we've been doing over the past couple of years is working on .NET Core and then .NET Standard. And when we were working on .NET Core, we came up with this new project format called Project.json. And MSBuild has traditionally been how you built .NET apps. But at the time, MSBuild wasn't open source. It didn't run cross-platform. And it also had kind of a lot of baggage. It was verbose, hard to edit project files manually, and we were looking at tools like Node.js, where it was really just simple. You just edit a simple text file, and that's your project. You don't need any complicated tools. And so we came up with this project format, which was had a lot of great features. So it's simple, human-editable project files. It doesn't explicitly list each source code file. it just, by default, it'll just compile all of the C# or Visual Basic or whatever source files you have in the directory. It could produce NuGet packages directly. Traditionally, what you would have to do to create a new NuGet package would be to create a new spec file, which listed all the things that would go inside the NuGet package and the metadata about the NuGet package. But with this format, all of that information was just directly in the project file, and you could just say, pack this up, and it would create a NuGet package. And the project could target multiple frameworks. So we're introducing this new .NET Core thing. We still have the full .NET framework. Maybe you have portable class libraries, UWP, Xamarin. You could list multiple frameworks that it would target, and it would compile the project for each one of those, which was pretty convenient if you needed to light up platform-specific functionality. And it also let you switch. You could have a reference to a NuGet package, but it was easy to switch that out with a local copy of the source. So if you find a bug, you just clone the source, and then now you're debugging, you're fixing the bug and using that local copy. So that had some great advantages, but about a year ago, we realized that we had to switch back to MSBuild. And there were various reasons for that. Everything else in .NET used MSBuild. And when we think about .NET Standard, we want you to be able to write libraries that will run on .NET Core, but that will also run on .NET Framework and Xamarin and UWP. And so all project types need to be able to reference .NET Standard projects. But references between something that was Project.json and MSBuild in either direction, just we couldn't make that work well. We had some hacks that kind of worked, but end-to-end, it just wasn't working very well. And then we have the tooling and the IDE. Visual Studio understands MSBuild projects, and we had written a completely separate piece of a project system in Visual Studio that understood this kind of, but there wasn't a uniform way for tools to work with .NET projects. And when you have other IDEs, other editors, like the whole ecosystem was built around MSBuild. And then MSBuild has lots of extensibility and power. You can pretty much do anything you want with MSBuild. And that wasn't really supported by Project.json. So if you just want to compile a set of files for a project, that works. Or if you just want to do something, some functionality that was pre-baked that we had thought of and implemented for you, then that worked in Project.json. But if you wanted to extend your build pipeline, there wasn't a good end-to-end way of doing that. For example, some people want to generate code files. You're using protobuf. And so you have a definition of your protocols. Before you compile your project, you want to generate C# code for those interfaces. And then after you compile it, you may want to manipulate the IL. There's some IL weaving projects like FODI, which will add iNotify property changed or do other transformation on the result of your compilation. And you could have like scripts that would run before or after build, but when you have a complex pipeline, that starts to break down when you want to support things like incremental builds, only building what's changed, or parallel builds, and things like that. My pet peeve was that Project.json did not support comments. That's something that if we had moved forward with Project.json, I think we would eventually fix, but the JSON spec does not support comments, so this didn't support comments. So we told everyone, hey, we're going to move back to MSBuild. But this was MSBuild. This is new project console app in .NET Framework in Visual Studio 2015. So that's quite a bit more verbose, doesn't have those advantages that Project.json had. And we said, we know that Project.json has these great advantages, and we're going to bring them to MSBuild. But the joy of open development is that we announced this change of direction pretty much at the same time that we made it, and before we had all of the details worked out of how that would actually work. So all we could really say was, trust us, it's going to be great. And judging by the reaction online, there were a lot of people who didn't really trust us and think it would be great. And that's quite understandable. But so since then, we've worked on making lots of changes to MSBuild and to Visual Studio and the project system. And so what we have today as of Visual Studio 2017 are MSBuild projects that look like this. And so this has basically all of the advantages that Project.json had. Now, it's XML, so if you prefer JSON, I'm sorry about that. But given that it's XML, it doesn't have lots of verbosity. It doesn't have lots of information that's not needed. The philosophy behind this new style of projects was to have sensible defaults that you could override if needed. And so the only thing you really need to specify about a project is, what am I targeting? What version of .NET Core or .NET Standard or what am I targeting? And here it's saying it's an exe, it's an app. That's how you say it's an app. And so we've kept all of those advantages of Project.json. The one that we don't have entirely is swapping out package references with source. You can kind of do that, but we will hopefully do work there eventually to make that a bit better. But everything else we've pretty much got. And so let's look at some of this. So for context, we've made lots of improvements. And what they apply to right now is .NET Standard projects and .NET Core projects and ASP.NET Core projects that run on the .NET framework. That's what we support with this new style of project. It is possible to try to use it with other scenarios, other full .NET Framework projects, and that's kind of a use at your own risk. If you are hoping that a lot of the Visual Studio features, such as designers and stuff for WinForms or WPF, or classic ASP.NET, a lot of the tooling in Visual Studio may not work. It might compile, it will probably compile, but a lot of the tooling won't work. And so we hope to bring this to more types of projects in the future, but right now that's what it's supported for. So let's take a look at this. So here I have a project, and let's look at what the project file looks like. So I'm going to right-click on the project here in Visual Studio, and I'm going to click Unload Project, right, because that's what I have to do to see the project file. But wait, what's this? Edit handbellhero.core.csproj. So I can edit this project file directly in Visual Studio without closing it. Hey. So what am I doing next? So here, and you know, the tools in Visual Studio still work. So I can modify this project, you know, by going in Solution Explorer, adding files and stuff. But I can also just type if I want. So if I want to add another package, I can say package reference include equals, what do I want? Know the time, right? And okay. And so now I have a package reference to know the time. Now, maybe I want to, by default, you see that I have a bunch of source files here, but and they're not listed in the file, but maybe I want to include something that's outside of this project folder. So I prefer to put this in a separate item group because it's a separate type of item, but it could go with the package references. So compile include equals .. /common/mvvm.cs, okay? Okay, so I've typed this, I have not saved. So, you know, I'm going to hit save and I have a pointer there. Yeah, you'll see it show up there. So let's move the mouse here, save. Oh, that's not supposed to happen. Whoa, demo fail. I must have had a syntax error there. That sucks. Yeah. Yeah, that was my clicker. I clicked down on the clicker, which eventually, apparently gives me an X. Okay. So now we see that that file showed up. So we'll just comment that out, save, it disappears. uncomment it, save, and it shows back up. Okay, well, this is a file, that's included from elsewhere, and it shows up here, and there's a little link symbol there, but maybe I don't want it mixed in with the rest of my source files in Solution Explorer. Maybe I want to show it somewhere else. So base equals shared. Okay, now save. So now that's saying put it in the shared folder. And this is new. That specific feature is going to be new in update 3 of VS 2017. So it won't work if you're just on the RTM release right now. But the link metadata here is where it shows it in Visual Studio, but that needed to include like the whole file name. So now we've added link base, which will just be the start of the link, and then if you have a glob, it'll include any recursive folders, and then the file name and the extension. Okay. Now let's see. What if I'm adding a new file here? So we're just going to copy a file here. Copy, and as I paste it, you can watch and it'll show up there in Solution Explorer. Paste. Hello. There we go. Okay, so I can just move files around, copy them to the project folder, and they'll just show up. But I actually don't want this file, right? So I can right-click and I can say exclude, and it's removed. And you can see it just puts, sorry, it put it up here. It just puts the exception to the convention in the project file. In VS 2015, you could use wildcards at the MSBuild level to include source files. And some people did that, compile include ***/star.cs. The issue with that is Visual Studio would happily read that, but anytime it wanted to make any edit to it, it would just expand that out into a separate compile item for each file. But now it kind of respects the defaults and just knows this is the piece that needs to be changed. Okay, oh man, I made a mess of this project. I just want to go back to what I had before. So I'm going to just git reset. And it's going to reload in place here, presumably. Is that the right folder? Yeah. Okay, beta software here. There we go. And so it's just reset back to where it was. It doesn't ask me, do you want to reload the project file or anything. It just reloads in place. And if I want to switch branches, same thing. Git check out, move files, I think. Move code. Okay, enter. And I moved all of those files to a subdirectory. I added a new package reference. I retargeted from net standard 1.3 to 1.4, but it all just works. Okay, and then another feature that was in Project.json and that we have is multi-targeting. Multi-targeting means to target more than one framework in a project. And we used to kind of call this cross-compiling. But cross-compiling kind of has another accepted meaning. It's like compiling on one architecture or OS for another one, like from x86 to ARM. And so we decided to use the term multi-targeting for the .NET of compiling it multiple times for different platforms. So all I have to do there is, instead of target framework, which is singular, I change that to target frameworks, which is plural. And then I can just have a semicolon separated list here. So I want to also target net 4.5, okay? I'm going to save it. In that case, it has to reload it. But now this project targets 2 frameworks. And if I go, I don't know. If I go in here, I have this context drop down. And so this shows the different target frameworks that I'm targeting. And I can switch between them and get IntelliSense and syntax highlighting and everything for each of those. I also have conditional compilation symbols based on that. So I can say if net 4.5, right? So that's grayed out right now because I'm in the net standard context, but I switched to net 4.5, and it's not grayed out. And IntelliSense and everything works the same way. And that's probably going to give me a compilation error, so let's get rid of that because it needs that. And then creating a NuGet package, right? So I can just invoke the pack command. Pack means create a package on this, and it'll build it, and it'll create a NuGet package. So start Windows Plus. Okay, so handle hero.core. This is my project. Bin, debug, and here's my NuGet package. So we see that we were compiling for different target frameworks. It's the same DLL, so it needs to have a different output path for each target framework. So that's what these folders are under here, and that's where the output goes. But the NuGet package is for all target frameworks. So we open that up, and we see we have a NuGet package that has the assemblies for the frameworks we're targeting. So very easy to create a NuGet package from a project with multi-targeting if you like. Okay. Okay, so what do you need? Where do all these tools come from? There's a couple things to cover. So Visual Studio 2017, that is the first version of Visual Studio that has a lot of these features, and Update 3 is coming out sometime soon and is going to have a little bit more. And Visual Studio includes an MSBuild, which runs on the full framework. That's the traditional version of MSBuild. It runs on full.NET, which means it supports targeting all of the different platforms, such as UWP, WPF, Xamarin. It's all built on that full framework MSBuild. And new in Visual Studio 2017, Visual Studio 2017 supports side-by-side installs, and so each copy of Visual Studio 2017 actually has its own version of MSBuild. And you invoke it using just call it MSBuild from a Visual Studio command prompt, and that'll set your path so that it's pointing to the corresponding version of MSBuild for that version of Visual Studio. We also have the .NET Core SDK. Sometimes we call this the CLI, or the command line interface. And this is what you'll download if you go to .NET and look at like the command line experience. Or it's available for Mac and Linux as well as Windows. So if you're doing cross-platform development, this is what you'll use. And so the .NET Core SDK includes a copy of MSBuild. That runs on .NET Core. And you run it with the .NET command. So the .NET command, that's the .NET CLI, and it has a lot of different commands. One of them is MSBuild, and that is basically the same as calling MSBuild, except it'll use the core version of MSBuild instead of the full framework. Hopefully, normally it won't matter that much, but when you start to get into your building projects that require tasks and targets that don't run on .NET Core, if you're trying to do some of this stuff, then it can matter. And a lot of the other .NET commands are kind of implemented as wrappers over MSBuild. So, you know, there's .NET Clean, there's .NET Pack, which invokes the pack target, just like right-clicking in Visual Studio and clicking pack, that invokes the pack target. So a lot of the .NET commands are implemented in terms of MSBuild. And then there's Microsoft.NET.SDK, and that is what you... So I get that from here. So SDK equal Microsoft.NET.SDK. That is what supports a lot of the simplification of the project files. MSBuild is a generic build engine, which includes a lot of functionality to build .NET apps. But the way that we made the project files simpler is we put a lot of it in this SDK functionality. Now that SDK is delivered as part of the .NET Core SDK. And in Visual Studio 2017 Update 3, both the full framework MSBuild and the .NET Core MSBuild will use this SDK from the .NET Core SDK. We have a problem with naming, if you've noticed. But that means that if you install the preview of Visual Studio 2017 Update 3 today, then to get the new support for .NET Standard 2.0, .NET Core 2.0, and some of the new things we've been doing in this project, like that link base that I showed. What you do is you install the update of this, and that will update. Visual Studio will use that, as well as the command line will use that, and you'll get the new functionality. So you can update some of this functionality out of band, and a lot of the .NET Core support and .NET Standard support will come that way. Global.json. So global.json is used to select a specific version of the .NET Core SDK, and it kind of applies to all folders below it, unless there's another global JSON nested under there. Generally, you shouldn't need to use this, except if you're still using Project.json. Then you need a global JSON with this in it to say, I'm going to use this version of the .NET Core SDK, which supported Project.json. Otherwise, don't use it by default is my recommendation, but if by accident we make a breaking change, then this is kind of the escape hatch, that you installed a new version and it broke something, then you can use this to say, no, don't use that new version that I've installed, use this exact version. It's not our intention to make breaking changes, although in MSBuild, everything is global, so any change that we make could conceivably be a property name that you happen to use for something else. But in practice, we don't expect there to be breaking changes in general. But you've got an escape hatch if you need it. So let's cover some basics of MSBuild. Properties. So properties go in a property group, and they're basically scalar variables. You've got a name and you've got a single value that goes along with it. Properties can be based on other properties. So here we have a version set to 101, and then here for the .NET 4-part version, we're adding a .0 to the end of it. So the way that you get the value of a property is with this syntax. You get $, and then in parentheses you have the name of the property. And then here we're just setting file version to exactly the same value as assembly version. This syntax for property value, you can use that in a lot of different places in MSBuild. Most places where you can specify a string, you can just put $property and get that property value interpolated in there. Conditions. So you can add a condition attribute to most things, actually, in MSBuild. So this is the defined constant property, and that's the compilation constants that will be passed to the compiler. So here we're saying we're going to take the existing value, add a semicolon in net standard if the target framework is net standard 2.0. Well, this is great that we have that capability. You can have arbitrary conditions, which is powerful, and sometimes you need that. The syntax starts to get not so beautiful here. And this normally wouldn't be too bad. It's just that, on the slide, the word wrapping makes it a little bit ugly. You can also put conditions on the property group. So if you're working within the constraints of what can fit on a slide, you could put that condition on the property group, and then it doesn't have to word wrap as much. And it means the same thing. So properties are single values, variables with single values, basically. Items. Items represent a list of values. And the element name is the item type, such as compile or content, reference, package reference. It can be arbitrary. So MSBuild items. Compile. These are what MSBuild generally uses for your source files. What's it going to pass to the compiler? Content. This is the content item type. And then reference. Now, items may or may not refer to a file on disk. So these refer to a file on disk, and usually it depends on the item type. Compile needs to be a file that exists. It's going to pass that to the compiler, and if that file doesn't exist, the compiler will complain. Reference here. Well, reference, because of the way it's used by the build process, it might be a file on disk or it might not. So here I'm referencing something that's going to resolve to something in the reference assemblies. And so this isn't a literal file in my project. But here I'm referencing a path that's this DLL on disk. And so Items might be files, they might not be. It depends on which items they are and how they're used. Items can have metadata on them. So, and again, items go in item groups, right? Properties go in property groups, items go in item groups. Items can have metadata. So items are a list of values, and each value can have corresponding metadata. So the value for this package reference item here is Newtonsoft.json, and then the version is 10.02. So this is metadata on that item. Metadata can be, as of MSBuild 15, can be specified via an attribute like this. It can also be specified as a sub-element here. You know, usually this attribute syntax is cleaner. That's why we added it. But sometimes you want it like this, especially if you want to put a condition on it. There's some cases where you'd need to do that. And just because that's the traditional thing that's supported, you'll see that a lot if you just browse through existing MSBuild code. So you can have wildcards for items or globs. And so compile includes **star.cs. So this means recursively anything, and then, you know, any file that ends with .cs. And then content include all the text files and copy it to output directory. Now, copy to output directory, that's metadata on that item or these item values that are going to be produced. And the build system knows about this type of metadata. Now, so when you have a wildcard here, a glob, it'll search the file system for everything that matches that and then create an item value for each match. Now, this has actually got a problem here. If you're going to end up copying all of the text files to the output directory, typically your output directory is under your project folder. So the first time you build, it'll copy it there. And then the second time you build, this would actually match in your output directory. So you'd have another text file, which would probably then be copied to an output folder under your output folder. And each time you build, you just get more files. So you can also exclude things from items, usually when you're doing a wildcard. And so here, since I'm doing it a couple times, I've defined a property, which is the pattern that I'm going to exclude. So I'm saying everything under bin and everything under obj, the output and the intermediate folders. And then I'm using that property value in my item includes here. So I'm saying include all of the C# files except the ones which are under the pattern specified by this property. So that kind of fixes the problem we talked about. Okay, that's items. So project imports. So you have your project file, but you can import other project files. And MSBuild calls all of them project files. Usually we think of the project file as just the main thing, your entry point that you're building. But the syntax is import project equals and then a path. So you might want to import some common logic for everything in your repo. You could do that by specifying the path here. Before we had these simplified projects, every single project that you got near the end would have something like this, which would say import project equal this MSBuild tools path, which is a built-in property to MSBuild under the MSBuild installation, and then Microsoft.C#.targets or Visual Basic or whatever. And so this was how the common build the build logic specifically for the .NET framework and C# was imported. Now with the SDK attribute, the Microsoft.NET.SDK that we've added, we kind of have implicit versions of those. And so the syntax is a lot cleaner and you don't have to have this kind of thing in your project file. So you can see here, the extension is .props. Here the extension is .targets. Those are conventions. MSBuild doesn't care what the file name is. But the convention is props file stands for where you put your properties. And those are the things that are imported near the top, so before the body of your project is evaluated generally. And then the targets would be what's generally imported at the bottom or after the body of your project. Okay, so how do you actually do something in MSBuild? Well, that's tasks and targets. So task is a unit of action. It does something. Create a directory, something with the file system maybe, create a directory, copy files, call the compiler, or some arbitrary computation or action. And there's a lot of these that are built into MSBuild, but you can also write your own in C# or another .NET language. Now you can't have a task by itself. Tasks go inside targets. So targets group the tasks together, and then they express the dependencies between those operations. And they do that with, depends on targets, before targets, and after targets. So these are attributes that you can put on a target to express, these are the dependencies between them. And so the set of targets that run and the order that they run depends on this graph of dependencies. And so it's close to a DAG, a directed acyclic graph. If there are any cycles, then you'll get an error. You have top-level targets, which are kind of the entry points, which are the things that you build, such as build, clean, rebuild, publish, and pack. And then those have, dependencies. And so when you say build, it'll go through its dependencies, walking the graph until it's completed doing everything that it needs to do. Now, each target is run only once. And so if you run target 1 and then you run target 2, but both of them depend on target 3, well, then it's going to say, I need to run target 1. Oh, before I do that, I need to run target 3. And it'll run target 3, then it'll run target 1. And then when it gets to target 2, it says, oh, I need to run target 3. It says, I've already run that. So a target will never run more than once in a single build. And so, I said there's a dependency graph. So this is an example of part of the default dependency graph. And, you can't see the details there, but this is compile. Compile depends on core compile, which is what I think actually calls the compiler. It depends on resolve references, which depends on resolve assembly references, which depends on a bunch of stuff. So there's a bunch of stuff that goes into compiling, and this is kind of the default set of stuff that it needs to do. So when you build a project, what targets does it run? Well, by default, it'll usually just run the build target. There's a list of rules about what it'll run by default. But if you say MSBuild or .NET MSBuild, it'll usually have the build target as the target that it runs. You can specify which target to run with /t command line option. So /t:\clean. That'll run the clean target. Now you've got .NET. And so just watch out about the difference between .NET Build and .NET MSBuild. When I started working with the .NET CLI, I was just using .NET Build for a bunch of things. That's what calls MSBuild, right? It turns out that specifically invokes the build target. So when I tried to do .NET Build /t: my custom target, it was running both of them, and I could not figure out why. And that's because it ended up translating into calling MSBuild /t build, because that's what this does, and then /t my target, which I had done. So that's just something to watch out for to understand .NET MSBuild versus .NET Build. Now, in the 2.0 .NET Core SDK, most of the commands that need it, such as build or publish or pack, will automatically do a NuGet restore before actually running them. So there's a .NET restore command, which will run NuGet restore. But in the 2.0 SDK, you most of the time won't need to do that. .NET build, .NET run, anything that needs it will basically do that for you. But .NET MSBuild would not. .NET MSBuild is kind of just raw invoke MSBuild with these arguments that I've specified. So this is what a target looks like. So it's got a name, and it can have before targets, after targets, depend on targets. So this is saying, run this before prepare for publish. So if you're publishing, somewhere in that graph of targets is probably a prepare for publish target. And then you put this in your project file, and it says run this target before that. And then these are tasks. So there's an exec task, which is built into MSBuild, and that means, start this process, call this command. And so here we're doing npm install and npm run build. Now, this is a common kind of thing you'd need to do, run this script before and after. This actually caused some issues. Because the way that MSBuild works is first it does evaluation of the project. So it goes through and it walks the project and walks through all of the imports, and it builds up, well, what are the properties first, and then what are all the item values. And then it starts to run the targets. And targets can also have item groups and property groups inside them that will modify those at the time that the target is running. But if you don't do that, then the values you get from the properties and the items are going to be whatever it evaluated during evaluation before you ran any targets. And so what this command target ended up doing is npm install and npm run build. That ended up, generating some JavaScript based on TypeScript and putting that in the www root folder. And by default, everything in the www root folder gets published. But that happens at evaluation. And so what would happen is that your first build, you wouldn't get the files that were generated by this included in the publish because at the time it was evaluating that, they weren't there. So that's the kind of more complicated thing you can run in. We've mostly fixed that. But if you had to do it yourself, it could look something like this. Now we've added an item group to the target, which is going to be, this is inside a target and it's going to be evaluated after these commands run. And so here we're saying include everything from www root except what was already in the content item and also our default item exclude. So our output and intermediate path and stuff would be excluded. And here we see a new syntax. So like for dollars, property name, that's how you get the value of a property. The @ symbol is how you get the values of an item. So this will kind of expand into everything that at this time was a content item. And so that says we don't want to add these things twice, but if it wasn't already in that, we're going to add it again. So that's useful to understand how some of this stuff works. This specific example, you shouldn't need to do that because we've built that into the web SDK. Okay, so you've got a build and it's not doing what you expect. How do you investigate what's going wrong? So 3 things: pre-process the project, look at a log file, or look at a binary or structured log. So what we're going to do is we're going to look at that. So let's see. Okay. Just get rid of the... Okay, so I'm going to build this. So first, what you might want to know is, I've got all of these imports. A lot of them come from MSBuild. Some of them are from this .NET SDK. Some of them may come from NuGet package. And, who is doing something? Who is setting this property value that isn't what I expect it to be? Or, what does this target look like? So a really useful thing you can do there is msbuild/pp, which stands for preprocess, and colon, you give it a file name, so msbuild.xml. Okay, so that when you do /pp, that doesn't actually run a build. That just does a walk through your project and all of the imports, and then it creates a flattened XML file that shows you the contents of everything that would have been part of that evaluation. Okay, so here we have it. So this is the output of that preprocess. So here we can see, this is the path of what was preprocessed. And then we start seeing the contents of that project. But every time that there's an import, then we'll jump into that import. So here we have that SDK equals statement. So that gets, that implicitly imports some files. So it tells you what it's doing here. And so that ends up importing this file. And so now we're in this file, and now we're in the contents of this file. So this comment comes from this SDK props file, and we can see what it's doing, and then it's going to end up importing some other stuff. So this is the import statement that was in that file. It's commented out, and then it also has a comment that says, well, this is what it ended up importing. And so this is basically going to show you everything that was affecting your build. And so if you want to know, who's setting a property, you can kind of look for that. Although, I can't spell. If you want a specific target, you can look for name equals strong name, right? So this is a target that's being injected from a NuGet package, for example, and you can look at what it's actually doing, what it's passing to it, what it's passing out of it. Now, sometimes if you're looking for something that are in the common targets, the targets files that come with MSBuild, those are sometimes kind of long. So, where is this actually coming from? Well, you scroll up until you see this kind of header, and it shows you where. If you end up looking at something in the common targets, sometimes you'll have to scroll up quite a bit. Okay, so that shows you what was evaluated in your project file, but then what actually happened. So then you want to create a log, and so you can do. I always do FLP verbosity or V equals diag, and you can look at the command line help for different options here. But what this means is file logger parameter. So that means it's going to use a file logger. And the parameter it's going to pass to that is V. Verbosity is diagnostic, so that's the highest verbosity. If I'm investigating something, there's different verbosities, but usually if I want to investigate something, I just want the full level. It's very verbose, but it might have something I need. It tells me exactly what parameters were passed to each task, for example, and what came out of them. So it's usually useful. So there I did a build, and then here, MSBuild.log. So you can specify the name of the log file, but by default it'll just be MSBuild.log. And then, so this has lots of information. Near the beginning it has all of it's got property reassignments, which is something new, but then it has initial properties. So this is, when it evaluated the project file, here are all the properties and their values. And then initial items. Right, same thing for items. So if we look for compile, so this had one compile item, program.cs. And this had, this item, the value was this, and then further indented, these are the metadata on that item. Okay, and then it will execute the targets. So here's where it starts actually building. It's got a bunch of targets that are skipped. Like most elements in MSBuild, a target can have a condition on it. So it's saying, well, I would have executed this, except the condition evaluated defaults. And then when there's actually something it does, it says I'm running this task, I'm passing this parameter to it. If it has output of that task, you'll get that here. It has all of that information. Now, so that's great. It's very detailed, but I don't think anyone's going to love looking through this verbose log file and trying to figure out exactly what happened. Searching through text log files is not great a lot of the time. Yeah. The question is there timestamps? I believe, I'm surprised it's not included. I don't know specifically. On the text log file, I'm not sure. Now, there is this summary at the end that tells you how long each target and how long each task took. So that can help you as far as the performance. The MSBuild supports arbitrary loggers, and so the logger has that information available. It knows when each event was raised. I'm not sure if there's an option on the text logger to actually include that, at each thing that it logs, but it's there. But this is somewhat useful and is what we had to deal with until recently. Now we can say MSBuild/BL, and we'll do T rebuild. Okay, so /BL means binary log. So this creates a binary log. This is a compact log format. It includes probably more information than the verbose log would do, but it's in a structured format. So you can't open it up and look at it in a text editor, but you can have a tool that runs over it and analyze it or displays it, and that does include the timestamps, and so you could do that. This is new. This is new in update 3. So if you have VS 15.0, it won't support this /BL switch, but 15.3 will. And so by default, it creates msbuild.binlog, and you can create a different name there. But you want to do something useful with that, so we have MSBuild structured log viewer. Okay, so this is a tool to view these binary logs, and it understands them and has a nice display here. Let's see. Okay, it's pretty visible. So this has basically the same information that you would have seen in that diagnostic log, but now it's in a structured format. And so you can see it built this project, and the initial properties were these, and the initial items were these, and it'll show the metadata on them. And then the targets that were run. It ran the rebuild target, and that caused it to run before rebuild, clean, this one, and then build. And so you can see the dependencies of the targets. You can also, you can also search. So, so if we want to say resolve assembly references, right? Then you get results here, and everything that matched resolve assembly references. And you can say, I just want the target with that name, and you can find specifically that target. And then you can go into that, and so this had an item group, which added some items, and then it ran this task. Well, this task had these parameters, right? So you can just drill down into all of the information. It's a structured format, so it's a lot easier usually than scanning through this enormous log file. So this is really super useful for analyzing your builds.
Question?
Yeah.
So I've been using this for 3 or 4 months.
Yeah.
And it's done by Krill and it's on the GitHub. Right. The biggest problem with this, going back to the question, is I want to know why my project rebuilds when I do an incremental build. Okay? And there's so many blog posts about finding you've got a C# file missing or something like this, and this sort of covers it. But even on the GitHub issues or requests, one of the things is it still doesn't tell me why. You have to look for is newer or some string description in this file. Why can't you just tell us why it rebuilt? If you've got this file, just tell us why it rebuilt.
So the question is about incremental builds and how can you diagnose why it is rebuilding something when you think it shouldn't have to do that work. Why can't we just tell you? Hopefully we will someday. Probably the binary log includes enough information for that, although I'm not absolutely sure. But that's just would be a great thing to have. Incremental builds are implemented by a target. Another thing that the target can have is inputs and outputs. And so MSBuild's incremental builds are based on timestamps. And so if you have a target that declares inputs and outputs, then when it goes to run that target, it'll compare the timestamps of those files. And if the outputs are all newer than the inputs, then it won't actually run any of those tasks. It's a good question. I mean, I don't have a great magic way to solve that for you yet. Okay, I think that's that for that demo. Okay, so a couple more things. Common build logic. So, if you have a repository with a bunch of different projects in it, sometimes you want to use the same settings for all of them. And something like this is what we used to do. And so this is a built-in function. So this is the syntax for calling some built-in functions in MSBuild. Get directory name of file above. And so that says, look in the MSBuild project directory and walk up the directory tree until you find a dir.targets file, and then return that directory name. And then, add the dir.targets to that. So we're going to import that if it exists. So then we have to have a condition with all of that repeated. So that's useful, and you don't necessarily need to do that. You could just specify /dir.targets, but then if you change your hierarchy around and you put it one folder deeper or shallower, then it stops working. So this is more robust, very verbose. With MSBuild 15, probably you want to just use directory.build.props and directory.build.targets. So this is built into the common targets now, and they will walk up the directory tree, starting with your project directory, and look for these file names, directory.build.props and directory.build.targets. And if it finds it, it'll import them automatically. And of course, the props will be imported very early, and the targets file will be imported after most everything else. And so, well, what can you do with that? You can have consistent package versions. So if you have a bunch of different projects and they reference a lot of the same NuGet packages, maybe you want to use the same package versions across your projects. And so you can just declare a property that says this is the version of Newtonsoft I want to use, and this is the version of Notatime. And in a project file, then you have this version metadata, but you use the property value here. So this would be common across your repo, and then you have the package reference in the project that uses this common version. You could put a package reference in your common logic if you wanted to reference that package from every single project. But here it lets you pick and choose and say, if I'm using Newtonsoft, then I want that version. Another thing you can do is a common output folder. So by default, the output folder and the intermediate folder will be under bin and obj in your project folder. A lot of people would prefer to just have one folder that was like under the repo root, so that it's cleaner and so that they can just delete that folder, get rid of everything, reset everything. So this is what you could do. You would put this in a property group in directory.build.props, repo root. So this is a built-in MSBuild property. MSBuild this file directory. So it's what file am I evaluating right now? Give me that folder. And so that's just a way we create a repo root property, both because it's shorter, and then if we're importing targets from other directories, then we still have that reference to the repo root. Anyway, and then base output path and base intermediate output path. Now this would need to be in an SDK style project for, I think, base output path is new in the Microsoft Net SDK. So you're saying put it under output and then MSBuild project name. So MSBuild project name is another built-in property. And so if you're building myproject.csproj, then MSBuild project name will be my project. And so this is if you want to have a separate folder for each project under this common folder. And so here we're specifying where the bin folder is and then where the obj folder is, base intermediate output path. The Microsoft.NET SDK, so when you say project SDK equals this, and I've said Microsoft.NET SDK, if it's a web project, it'll be Microsoft.NET.SDK.web, and that includes some additional logic for web projects, like handling the www root folder and some other stuff. But that will also use this basic SDK, so there's common stuff that'll apply to both. Okay, default items. So, you didn't see compile items or embedded resource items in your project directly. By default, it'll just include everything in that project folder. And, you can also include additional stuff outside of that project folder, and you can exclude stuff by saying compile remove equals filename.cs or whatever you want. You can disable this entirely per item, so enable default compile items, set that to false, and you won't get any default compile items. Enable default items, set that to false, and you won't get any of those defaults. Assembly attributes. So when you're converting from existing projects to SDK-style projects, you probably have an assembly info CS under your properties folder, or maybe under a common folder or something that you've changed. You don't need that anymore. We just have properties that during the build, those properties control assembly attributes that get generated. And so usually that's better. But if you already have an assembly info.cs and you want to keep using that, you can disable that. So you can, each attribute that would be disabled has a property that you can set defaults to disable it, or you can say generate assembly info, set that defaults, and that'll disable it altogether. The default values of these come from properties like version, file version, company, stuff like that. Okay, so I have this URL here, and then I want to show you one more thing. So this tinyurl.com/ndcoslo2017-MSBuild. That's how you can get to this, and this has some useful links, documentation, structured log viewer, which I showed, and I said that that was a new thing in update 3, but MSBuild also supports custom loggers, and so this project also has a custom logger. So if you're using MSBuild from VS 2017 or probably even earlier, this project will let you use a custom logger which will log the same information, and then you'll get the same kind of thing. Project Simplifier. This is a work in progress tool, but what it'll do is it'll take your project and evaluate it and then figure out, convert it to this new SDK style of project. So if you want to take advantage of Microsoft.NET.SDK, this project will help you do that. It's still a work in progress. I tried it out, at preparing for this presentation, and it left some stuff in there that I still wanted to delete, but hopefully that'll improve over time, and it's still pretty useful. And then resources, tips, and the documentation is actually pretty good if you want to learn. And I think I'm over time. So thanks so much. I'd love to talk to all of you about MSBuild, about .NET Standard, portable class libraries, whatever you want. You can email me. You can contact me on Twitter. You can come up afterwards. And there's that link again. Thanks very much. Don't forget to vote.